Welcome everyone. In this video I'm going to talk about stepper motors and stepper motor controlling again. So if you have been following my channel, you can see that I've been working on a control panel for stepper motors for quite a while, and I always added some functions and improved it and so on and so on. And then that control panel is now in this nice box. So it has a nice USB cable. As you can see, we have buttons and a rotary encoder with a button as well. And we have a small display which shows us all the necessary information. And then we have these very nice terminals which have different functions. So we have two limit switches, for example. So we have terminals for them. And the idea for the limit switches, or the idea behind the limit switches, is that you want to use your stepper motor, for example, to drive a linear actuator. So you have a linear carriage and a linear rail, and then the stepper motor drives a shaft which drives the motor, and then the motor drives the carriage back and forth. So you have a starting point and you have an end point. And first of all, why you want to have these limit switches is that you want to have an emergency step. So if your carriage runs to the end, either if it's a beginning or the end of the linear carriage, you want it to stop. And then this can help us by automatically shutting down the motor when one of these switches are triggered. But also you want to implement, for example, homing. So you want the linear carriage to return to the same position all the time. And they are also used for that purpose, and everything is implemented in this box. So that's why we have the limit switches. And then the other output here on the left side, these four terminals, is for stepper motors. So I have a video which you can see up here in the corner, and I showed you that basically you can drive any kind of stepper motor driver with the same code and same environment and so on, which can work with the step and direction pins. And for example, in this case, I will run this system with a DRV8825 stepper motor driver, but in fact I could replace this with an easy driver or a TB6600 and so on, because they can all work with the step and direction pins. So coming back to the control box, this is a very universal control box, because you can use this kind of thing with any kind of let's say popular stepper motor drivers, because they work with the same principle. You just need to provide them the direction and the step signal. Sometimes they need an enable signal as well, but that is also here. And technically that's all. And now I'm using this driver in a breakout board, as you can see. So a further advantage of this breakout board is that I can set up the microstepping here with these tiny switches. So that's very nice. And basically this is all about the control box. And why I'm making this video is because I implemented some new stuff, partly based on some questions or feedbacks I received in the videos. So I will show you the new stuff. But also, as you can see, I have a nice little toy here. As you can see, this is sort of a linear carriage. So this moves back and forth. And this frame is actually designed by me and printed by me. So I made this here at home. And what is inside this is basically salvaged from a DVD ROM or drive. So I have a bunch of this. Luckily I could save a few. And I removed the main parts. And I show you the main parts which are introduced to this system, or included in this system. So this is a normal tiny stepper motor without any kind of carriage or nut on the main shaft or screw, and it has the regular 4 pins. And the most important thing about these is that they are very, let's say, weak, and by weak I mean that they need very tiny current to drive. So actually this DRV8825 is a bit of an overkill. I should have used the easy driver that runs them perfectly, but I don't have a working piece now. So I will drive it with this driver, but for only a short amount of time. And then also what I salvaged from the DVD drive is that these two sticks, which are actually guiding the carriage inside the DVD drive. And as you can see, I also used it here to have a straight rail for this carriage. So this is the other part. And then one of the most important part is this thing. So as you can see, there are two teeth here, and actually those two teeth get aligned with the thread here, and then they grab the thread, and as you drive the shaft, it allows this piece of plastic to travel up and down. And I can show you exactly what I did here. But first of all, what I did, I actually removed all these crap, except I kept, let's say, this part which is visible. So I made a straight cut here, keeping this small thicker piece here with the spring as well. So I kept this let's say 2 millimeter thick wall, and then I put it in a small stuff here. I will show you. So I made two holes on the top of this block, so that allows me to put two screws which basically fix the shafts, so I can fix them at place. So now I made this thing free. So how I printed this, as you can see, is there is an empty space here, and now hopefully you can compare the two things. So as I said, I kept this line here. I don't know how to call this, let's say wall, but other than that I removed all these parts. So I just basically made a straight cut and then filed it a little bit to make this thing flat. And I designed this block in a way that it fits this thing perfectly, and it allows a little bit of springiness to it. So then I can just find the thread with this thing and align it. So now it's aligned, and then I can put these things back. So we have this tiny carriage. Of course, I will share the 3D files for this, so you can print it yourself. And this is a very easy job to print. I think it took like 25 or 30 minutes total with these two parts. And it's more or less precise. I still have some problems with my printer, so some parts are not so nice, as you can see it here, for example, but it was decent enough to put everything together. And most of these things are more or less the same in different DVD drives, because I removed these two things from two different brands, and they seem to be the same dimensions and everything. So hopefully if you want to do the same, it will work for you as well. But now what I want to show you is that I want to show you the new features in this box. So I will power up this box with a regular mobile charger, and then we let this thing run. So a lot of people are interested in this back and forth motion, which is just some kind of oscillation between two endpoints. So what I did, I implemented two type of, let's say, ping pong or table tennis kind of motions, and that is the main attraction of this video, is that one is based on steps. So what it does is that you move your carriage somewhere, which is a starting point, and of course you have to be aware of your positive directions and so on. So that is unique to all systems, and you have to set it up when you build your thing. But you select one of the points on this carriage, and then here in this menu, you can decide how many steps you want to move away from that point. So the carriage will move to that point, and then it will return to the initial position. So this will be the oscillation. So you just go somewhere. Let's say we just stay here. The position is 0. And then I say that, let's say I want to go, I don't know, 80 steps away from this position. So then the stepper motor will go 80 steps away from this position. It will decelerate, stop, and then it will go back to 0. And then when it approaches 0, it will decelerate, stop, and then it will go back and forth until we press the stop button, which will stop the things. So let's test how this works. So it's almost perfect, but my carriage is falling apart. Sorry for that. So now you can see how it works. So this was our initial position, and then we are going 80 steps away, which is right next to my pinky finger, and then it goes back to 0. So it oscillates between 0 and 80 steps position. And this is very good, because here you don't have to do anything, you just have to go somewhere. I will show you how. So we stop right here. So whenever you press the stop button, it will stop there. So now this is our starting position. So if I go back here and I say that I want to step 80 steps, then the carriage will move to this direction, and it will be very close to the motor. So I just step, let's say 50 steps instead of 80, sorry. So it will move just a tiny bit. But yeah, the advantage of this kind of implementation is that you entirely depend on the number of steps, and you as a user, you don't really need to care about a lot of things. You just say that, okay, I want to go X amount of steps away from this position where the carriage is right now, and then the system will do it. So we are now at 50. So I just press start, and hopefully everything will work as I want it to work. So it works. So we go 50 steps away from our current position, and then we return to 0, which was the initial starting point, and then we go back and forth. So as you can see, this was easy. The motor is a bit hot, so I let it rest. So meanwhile I explain the new stuff here. So what we have here is another oscillation, but it is based on limit switches. So now what this system will do is that it will rely on these two limit switches. This is limit switch number 1, and that's supposed to be at the positive end. So basically your very I don't know how to say, very zero or very origin position. So that's your absolute starting point where you want to start. And then if you go towards the other end of the carriage, that will be your very positive part. So here is 0, let's say, and here is, I don't know, 5,000 steps, which is your other end point. So this will be at the 0 origin, and this will be at the positive end point of your system. So what this does is that the software runs, or the code runs, and then it goes towards the positive direction as long as it doesn't hit the limit switch at the positive end. So let's say on the right hand side on the screen, but again this depends on how you set up the system. And then when this limit switch is hit, it flips the direction and it starts to go to the other way until you hit the other limit switch. And then when this limit switch is hit, then it flips the direction and it goes towards the other limit switch. So it doesn't take care about anything else, just the limit switches. So you can have like 1 millimeter long gap between the two limit switches, or you can have 1 meter long distance between the two limit switches. This will move regardless of those distances, and it will do the task. And of course it uses all the deceleration, acceleration, and so on and so on. So now I have to be quick because I cannot really attach the limit switch here. So all I have to do is I give back the power to the control unit here. And then I start with this and see if I fail or not. So I will try to explain what I'm doing. So when I see that the carriage approaches the right side, like now, I press the right limit switch, and then I press the left, right, left, right, left, right, and so on and so on. So you see that I can even change where they go, because it only depends on the limit switch and nothing else. And you can see that it accelerates as well, and so on and so on. And I was not fast enough, but I stopped it at the end, and this was it. So this is the limit switch based implementation of this ping pong stuff. And I think this was all regarding the two new things that I wanted to show you. So once again, I upgraded this box, and you will see the new code and everything. And I will explain the new parts of the code only in the end of this video. And then you could see that we can drive this nice little stepper motor salvaged from a DVD drive. And we can build this carriage, which can help us in a lot of different things if you want to move some small objects, which I will do in a future video actually, and that will be a very cool project, but I don't want to reveal it right now. So if you want to move something very small thing with a relatively high precision, then you can do it with this carriage. And now what you can do is that you can modify this and put this thing on top of it, and now you have an XY table. So there you go, it's a nice stage. So if you want to move a small object, you can do it with this system, and this is like a very compact and tiny system, but you can move your object in a very fine scale. So for example, if you are a macro photographer and you have your object attached to this stage, and you have the lens somewhere here, then you can step this back and forth. You can use it to stack the images, or just move your subject into focus or something like that. So that can be something cool for example, macro photographers and so on. So now I think I talked too much, so I will go to my computer and I will show you the new parts of the code and explain it how they work. So let's go to my computer. So we have arrived to the source code, and as I said, I will not explain all of it, but just some new parts which are the most recent updates. If you want to have this source code explained line by line, please check the top right corner, because I have already explained this several times. So I just put the most recent video there and you can check it. So what we have here is that we have a new limit switch, and that is nothing else than I just duplicated the previous variable, and then I just gave a different name to the variable. So now it's limit switch number 2, and of course I assigned it to another pin. So nothing fancy here. And then we have a new variable here, which is the stepper ping pong steps, and that is just the amount of steps that we want to move away from the current location when we do this kind of oscillation. And if you get a positive number, it will go away from the initial position in the positive direction. If you give a negative number, then it will go in the other direction, because this is basically just a real relative movement. Then we have this ping pong initial position. This does nothing else than just remembers the position where we started this oscillation, and then the final position is basically this initial position plus these steps defined here. But I want to store them in variables because that will be important for us later, as you will see. So then we store it. And then we have this limit switch temp position. Temp stands for temporary. So this is used for the limit switch based operations. And then we just want to remember the position where the limit switch was triggered. So this is what we do here. And then we have these 4 variables. Basically, if we selected or enabled the step-based oscillation, and then if we selected or enabled the limit switch based oscillation. And then these selected ending variables needed for the menu, and these enabled ending variables are needed for the main code, for the loop. And then we have this, which can be familiar to you if you have checked my previous videos where I did similar exercise, because I borrowed the names of the variables from those videos. So this is just a clockwise, let's say, movement of the shaft, and this is the counterclockwise movement of the shaft. And this is just some kind of indication for our code. So the code knows that the motor is now moving in the positive direction or it is moving in the negative direction, because that will be important for us to be able to code the flipping of the direction properly. So this will be like revealed later how I did this. And then of course we added the limit switch 2, and that is PB10 here, and that's all. And of course we have to define it as an output. And I'm polling these pins. I'm not using interrupts because we have switches, buttons, and so on. And if you use this with an Arduino, you will be in trouble, because the Arduino only has, for example, the Nano or Uno only has 2 interrupt pins. So instead of that, I'm just using polling method. And then basically that's all about the pins. So now we go to the main loop, and if you remember from the previous video, if you checked it, some things are updated based on some other parts of the code. But now I added these 2 lines, and what we have here is that if the step-based oscillation is enabled, then we run this function. Otherwise we skip it, of course. And then if the limit switch based oscillation is enabled, then we run that function. And they are written in a non-blocking way. So they will do something to the variables in the background, and then the stepper.run will do something based on the instructions. So let's see these 2 functions. First, the step-based function. So I told you that we need to keep track of the clockwise or counterclockwise directions, so that's what we do here. So what we do here is that if the clockwise movement is false, then we enter this part, this branch, and we tell the stepper motor to do a absolute movement to the final position, which is of course calculated in a previous step, where we actually enter this menu and approve the numbers. And then while we are moving, we are checking how much steps are left, and when this becomes 0 here, then we change the value of the variables. So then this becomes true with this kind of change here, and then this becomes false. And that means that in the next iteration of the loop, the code will skip this part, which is highlighted right now, and it will enter this part, because as you can see here, the CW became true and the CCW became false. And only if these 2 conditions are fulfilled, we are able to enter this part. And then this will instruct the code to move backwards to the initial position of our step-based oscillation. So then it will go back, and it will do that as long as there are steps left. And if we did all the steps, then we can enter this if statement here, or if condition, and then we flip the status of the variables again. So now the CCW became true and the CW became false. So then this will be skipped in the next iteration, but since the CW is false, then the highlighted part will be done again. And of course this goes over and over as long as we don't stop it by pressing the stop button or pressing the limit switch. And then just to talk about this ping pong final position, I will look this up where it is located, and I will explain it how it is calculated. So now we have to focus on the highlighted part here. So this thing is actually inside this up button pressed function. So whenever we press the up button and we have the ping pong step menu item selected, then we enter this part. And when we enter this part, of course we allow this thing to be fulfilled or performed. So then this means that in the main loop the code can enter the function which I just explained you a minute ago, and then we save the initial position, which is the current position of the stepper motor right now, and we also calculate the final position, which is basically just the current position which we have now plus the stepper ping pong steps. And actually I can speed this up because this current position takes a lot of resources. So I can do like this, and this makes more sense. So we read the initial position, which is just the current position of the stepper motor. So as I showed it in the demonstration, you can start this function wherever you are with the stepper motor. It doesn't matter, because everything will be done based on that location where you are starting this function. So we looked up our current position, and then we calculate the final position, so that will be the end point of the oscillation based on the initial position plus the defined number of steps. And that's all. So this will go over and over. So loop enters, we go through these functions which I'm highlighting. This is now enabled, so we step in, and then we check those two booleans, whether the clockwise or counterclockwise direction should be performed, and then we just give the instruction to the library, and then the stepper motor will move based on the instructions performed in this stepper.run. So now we have to check the limit switch based function. So let's go to that and let's check how that works. So this is a little bit lazy programming, but it works. So I believe that this can be improved, of course, but I just did not put too much effort in this. As long as it works, it's okay for me. So what we did is that this function runs with every iteration of the main loop. And then what it does, it comes in and check if one of these are fulfilled. And this simply does the following. Whenever you press one of the limit switches, we flip the direction. And of course, the most important things that we have to take care is that whether your limit switch value becomes 1 or 0 when you press it. So you have to check this. And what is your positive and what is your negative direction, and what is your positive limit switch and negative limit switch when we are talking about the starting point and ending point of your linear carriage, for example. So then based on that, you have to select this either 1 or 0, and you have to define these numbers either positive or negative. So then let's say we are moving in the positive direction. So then once after moving a lot, we hit the limit switch number 1. So then this becomes 0 and we enter this part. So now the stepper motor is instructed to move in the negative direction and move a lot of steps. This is technically infinite amount of steps. You will run out of the carriage earlier than these steps. So then we move, let's say, indefinitely in the negative direction, and then we go towards the limit switch 2. And whenever we hit the limit switch 2, then this variable becomes 0, so then the if is of course here fulfilled, and then we instruct the stepper motor to move in the positive direction, again indefinitely. So this is how it works. And how it starts, that starts with pressing the up button, of course, so we have to look it up how it works. So we are in the up button, press the function, and then we have to see this. So nothing else happens, is that we just start to go in the positive direction from our current position, and we of course also enable this ping pong limit, which is the limit switch based oscillation. And based on this limit switch, I have to come to this limit switch pressed function, because now we are working with the limit switches in two different and independent parts. So one is the oscillation, and that should be independent from the other function of the limit switches, which is this, what you see on the screen. And this is basically the homing, parking, or emergency stop part. And this is very simply treated. So if we have the limit switch based oscillation enabled, then we just neglect this whole part here. And what this whole part does is that whenever you go towards one of the limit switches and you hit the limit switch, then we remember the position where the limit switch was hit. We do a soft stopping, but immediately we have this run to position, which will a bit more faster stop. And then after we stopped, so the speed is 0, then while the limit switch is still pressed in, which means that its value is 0, at least in my system, then we move in the other direction, and that will basically park the stepper motor at the current position, which is actually not triggering the switch anymore. So basically we just release the switch with this part. So we press the switch, so we do some stuff here, and after that we just release the switch by moving the other direction a little bit until the switch is not released. So as long as this is 0, switch is pressed in, we go in the other direction. And what I did here is that I set the triggering position as the current position, so basically this. And I don't know if this is a good practice, you have to check it yourself, but for me this sort of makes sense. And then of course the same described for the other limit switch, with one tiny difference, that this limit switch is supposed to be at the other end of your linear carriage or whatever. So when you are like parking after the limit switch is pressed, you have to move to the other direction. So that's the difference. But once again, if you are doing the oscillation with the limit switches, then these parts are of course have to be neglected, because otherwise that would confuse everything in the code. So technically this was all. So what I wanted to show you is that I have this tiny control box which can be used with any kind of popular stepper motor driver. I wanted to show you this tiny linear actuator made of salvaged parts from a DVD-ROM, and you could see that it works nicely. And then I wanted to show you these two different implementation of oscillation. And before finishing the video, I want to show you some other stuff which might help some people. So if you go to my website, first of all, you can see all my projects, of course, but what is more important, that I have this menu called Tools. And what I did here is that I took pictures. These are all my pictures. I took some pictures of all the products that I'm using, so you can see that we have a lot of different stuffs. Especially we have a lot of things for stepper motors, for example. You can see the different drivers I'm using. You can see limit switch, and then I have different tools. I have different products related to coolings and so on and so on. And these are of course with some affiliate links. So if you want to help me and if you want to support me, as well as you want to buy the same parts that I'm using, just feel free to visit this. I will put the link in the description, and hopefully this will also make you or make your life a bit more easier, because at least you can see the product, and then if you just click on one of these products, it will lead you to the website where you can possibly buy them. But of course it's not mandatory, but if you want to buy it somewhere else, at least you can see the product, how it looks, and in my videos you can see them in action. And of course I have these projects as well, so anytime you need to look up some kind of stuff like stepper motor related things or other kind of things, lectures, just come here and check what is available. So I hope that this video was helpful. I hope I could provide some new information to you. I hope you learned something, and see you in the next video.